conical pendulum is a special type of circular motion, mainly because we have forces that are at an angle. So not all the forces are going to be exactly horizontal or exactly vertical with the conical pendulum. So let's just say, for example, we have a pole. And let's say this pole is attached to a string, and the string is coming down like this. And let's say we have an object at the bottom of the swing. Now, the bottom of the string. So if we're going to swing this object around in a circular path, it's not a perfect circle, but it's going to be something along those lines where the object is going to just move in a horizontal circle. Now, the fact that it's moving really in a horizontal circle, if you look at it from side to side, is important. Let's just say we know a few things. Let's just say we know the length of the string. Just going to call that L. Let's say we know the height of the pole. We're going to call that H. Let's say we know the radius. Let's say we know the radius of our circle. We'll just call that R. There are a lot of different things that we can find here if we just know 2 out of the 3, because we have a right triangle here. So since we have a right triangle, if we knew the radius, if we knew the height, we could find the length. If we knew the length and the height, we could find the radius just using the Pythagorean theorem. But the other thing that we could find, in addition to the other length, the other side of the triangle that we might need, is we could also find the angle. And the angle here is kind of important. So we could find the angle there using either inverse sine, inverse cosine, inverse tangent, depending on what exactly we have given to us in terms of our sides. Now, the reason why that's important is because if we actually look at a free body diagram of the object, we have tension. So we have tension in the string going up at this angle. We have the force of gravity that's going downwards. Those are basically the only 2 forces we have acting on the object when it's swinging in this conical pendulum. Now, that's important in the sense because we know that we can find the x component of tension and the y component of tension as long as we can find this angle theta. So as long as we can find that angle theta, this might be the angle up here, theta, we can use that in our trigonometry to find our tx and our ty. Why that's going to help us is because the object itself is moving in a horizontal circle. Even though we have a force of gravity that's acting on it that's a little bit more so than a normal horizontal circle that we would look at, it's still moving in a horizontal circle, which means that the y component of tension and the force of gravity are equal to each other. It's just moving side to side. So since it's just moving side to side, we know that these 2 are going to be equal to each other, which is going to help us in a lot of different ways, depending on what we're trying to find with the conical pendulum. Also, we know that the x component of tension, since it's moving in a horizontal circle, this is going to be our inward force. So the x component of tension is the agent of our centripetal force, which means that the x component is equal to mv squared over r. So that's also going to be helpful if we're looking for mass, if we're looking for velocity, if we're looking for radius. So really what happens in the conical pendulum is we have these 2 different equations, and more often than not what I'm going to do is I'm going to give you a problem where you're going to have to use both of these equations, like a system of equations, in order to figure out what you're missing. But it's important to know the conceptual setup of why everything works the way it works with a conical pendulum. It's important to know that the y component of tension and the force of gravity are equal to each other. And it's important to know that the x component of tension is going to be our centripetal force. So I'm going to give you some different example problems. We're going to be looking at some values. We're going to need to use this setup in order to solve some of those different problems.